Hi, my name is Naveen Gunasegaran and my student number is 220534758. Today I am going to present my assignment. In this video, we are going to see first is VBoards, second is Tinkercad, third is CAD design, fourth is Multisim. Now let's start with the VBoards. Now let's see the VBoards. This is my robot and this is my target which was placed behind the box. Now let's start the simulation. First part is the pre-programmed moment, which is square and figure 8 trajectory. In console we can see the GPS and IME values which are dynamically updating. This is my code. I separated every devices with some commands. First is ultrasonic, second this is 3 cameras, and then this is 4 sensor, GPS, IMU, and then motor values. In the while loop, first we are seeing the pre-program moments. This code is for square moments and this is for trajectory, figure 8 trajectory. After pre-program moments, this code get activates and activated the ultrasonic for obstacle avoidance and finding the target. And this code, the step 2 is for finding the path to home position. That's the end of the code. Now it gets avoid the wall and gets rotated. Nice. I moved the box to intercept the robot path, otherwise it will take some time to find the target. After finding the box, the robot stops closer to the target. Now pause the simulation and place the box on top of the robot. Okay, let's resume the simulation. After resume, the robot finds the home position and goes back. Now I'm fast forwarding. After getting closer to the home position, the robot correcting its rotation. After reaching, it stops. This is the end of the WebBot simulation. Now let's move forward to the Tinkercad. This is my circuit in Tinkercad. I used 4 sensor, left and right ultrasonic sensors, and I used dip switch for camera alternative. Then this is right and left motors are connected to L293D microcontroller for DC motor, which is used to change the direction rotation of the motor, and I used 2 9-volt batteries which are used to power the DC motor. All the sensors and motors are controlled by using Arduino Uno. Let's start the simulation. First, pre-programmed moment, which is square and figure 8 trajectory. It will take some time to finish. In the meantime, let's see the code. Here I am defining the variable pins with numbers. Next is for motor, ultrasonic. First is for motor, ultrasonic, force sensor, and other sensors. Then this is for pre-programmed moment for square. The next is for circle moment, figure 8 trajectory. This code is to find the target. and this code is to find the way back to the home. These are the functions for ultrasonic and DC motor. That is for left and right ultrasonic, and other is for DC motor function to control the DC motor. Now I am fast forwarding the video to the end of the pre-programmed moment. Now the pre-program moment came, and there are 4 switches for camera 1. If we turn on the camera and the distance sensor value is less than 200, the motor stops and wait for the next process. The motor stopped. Now if we change the force sensor value greater than 8.85 Newton, the motor gets activated and rotates at opposite direction. Because the camera 1, 2, 3 are at 0. If we activate the camera, now the both motors are rotating at same direction. This is the end of the simulation for Tinkercad. Now this is the camera module for Arduino Uno. The right side has some camera pin information and the original image of the camera. The left side has the schematic diagram of OVA module. Next, I created a circuit diagram for IMU and GPS module, which was designed using freezing software. Now we are moving to the CAD modeling. For CAD design, I used PTC Creo 6 software, which is similar to Inventor. This is my robot body, and I used 2 ultrasonic sensors, 3 cameras which are placed in vertical. It has 2 driven wheels using motor and 1 free wheel, otherwise called as ball caster wheel. On the top of the robot, it has force sensor to detect the box. Inside the robot, we can see the Arduino battery pack, 2 DC motors which are used to drive the wheels of the robot, and this is for cable management, which can be used to manage the cables for camera and ultrasonic. And that is the end of the CAD part. Now let's take a look at the Multisim. This is force sensor is created using Wheatstone bridge with 5V power supply, DC supply. I used 3 1.3K fixed resistor and 1.3K variable resistor, and connected to amplifier to amplify 5V, which can be used in Arduino. Now let's start the simulation and open the oscilloscope. Now I am getting around 2.5V when the resistance is 100%. If I reduce to 0%, I am getting around 5V. Next we are going to see about 555 timer. This timer is used to turn on and off at certain frequency. The 555 timer, you having the frequency of 4758 Hz, which was my student number. By opening the oscilloscope, we can see the square wave generated by the timer. In this circuit, we used AC current source, which was act as a receiver, and it was set to my last 4 digit of my student ID. First, the input current passes through the current to voltage converter and passes through amplifier, which was seen in the oscilloscope. We can see the difference. Next is the bandpass filter, which was created using the website called analogdevices.com. After the bandpass, the voltage passes through the full wave rectifier, which is used to convert AC to DC. We can see using the oscilloscope the difference between before rectifier, after rectifier. Now the rectifier voltage passes through the low pass filter to eliminate the high frequency. After the low pass filter, we are amplifying to 5V DC, which can be sent to Arduino Uno. We can see using the oscilloscope. In the oscilloscope, we can see the red line is the result getting from the low pass and the other is the result getting from the amplifier, which was 5V. This is the end of the distance sensor explanation. Now we are going to see about the comparison of two codes, which was VBOT's and Tinkercad code. Thank you.